Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Right, so inshallah in this class we'll discuss to a new topic, which is CNC. Right, so in our class we already covered the topics of PLC and also pneumatics. So we have done with this big two as the topics that we covered supposedly before the mid-term exam. All right, so your mid-term exam will cover only these two big topics, inshallah. All right. So in this class we'll continue with a new topic, which is CNC. All right, and let's go to start with this class. Right, so CNC, do you know what is CNC? Right, so I think you already seen this in your workshop before, in first year or something, first year or second year, right? So CNC is computer numerical control, right? C for computer numerical control. All right, so why is called CNC? All right, so CNC is form of programmable automation in which the mechanical actions of a machine tool or other equipment are controlled by a program containing coded alphanumeric data. All right, so this is why it is called CNC. All right, because the programming of the CNC, wait, is pen. Okay, so the programming of the CNC will use this alphanumeric code. Right, what is alphanumeric? Do you know? So alphanumeric data represent relative positions between a work head and a work part. All right, okay, so before this we see the coding for PLC, which is in term of ladder diagram. All right, as well as pneumatics, we have the diagram like normal electrical circuit. But now CNC we have in term of programming. All right, so codes. Okay, so how it is coded is using alpha numeric. All right, alphanumeric is the combination of alphabet. All right, alphabet, and also numeric, which is number. All right, so it is so you, after this you will see that you will have your line of code consisting of something like this, and 05 G21 and so on. Okay, so so in this course we only be covering the programming part of the CNC, right? So we won't go into much detail on the mechanism, on the instrumentation of the CNC, but we will focus only on the programming part, how to program. Okay. So let's move on. So this programming or the CNC code, we call it part programming. Okay, part programming. Okay, so always in the examination also we always use something like develop the part programming for the workpiece, like in this figure, for example. Okay. So you need to come up with your own program or your own code, so that the end product will be as the figure. Okay. Okay, this is example of CNC. So from the program, we download it into the control unit, and then this control unit will have the interaction with the mechanical or part of the machines, and then it will machine as intended in the program. Okay, so this one like a normal computer. So these are some of the examples of CNC. All right, so I think all of this you can also see in our mechatronics shops and labs as well. All right, so we have this one. So I think Dr. Tanvi have this one, this big CNC in his lab. All right, or you can go to the robotics lab in, I think in is E0. We also have some of the CNC machines near the robotics lab. All right, the ground floor of E0. Right. Okay, so uh, coordinate systems in CNC, right? So for flat and prismatic block like parts, this one for normally for milling and drilling, but this one using a normal Cartesian coordinate system, right hand rule, right? Like this. Still remember, X, Y, Z, and the rotation with respect to each axis. Okay, so you need to to cover this one first before you go through the CNC. All right. So this one. All right. So as for the rotating parts, so I think this one you also have done in your first year in workshop. So you did the turning, right? Using turning machines. All right. So you have a rotating workpiece, right? And then you will machine it using the X and Z direction, right? Of course, in turning, you don't need Y axis, all right? Like this. So the workpiece will be normally in a cylindrical shape, right? And it will be rotating with respect to Z axis. All right, so for CNC, you can use it either for point-to-point or continuous path system, right? So point-to-point, for example, drilling, right? So you go to first point, you go down, drilling, go up, and then move to second position, go down, drilling, and then retract and go to the next point, right? So that is a point-to-point system. And then the second one is continuous path system, normally in milling, for example. All right. So instead of point to point, it will go like in one continuous path. Okay. To make a contour or uh, uh, other shapes as well. All right. Okay. So this point to point, for example, drilling, go to first point, second point, third point. Okay. And then continuous path. Right. So starting from here, you can cut the workpiece like this, right? So either you want to go clockwise, right, for example, or anti-clockwise. So it's up to you. You can determine by yourself using your code. Okay, of course, this one you have the tool, and this one is the tool path, right? Okay, so in CNC you have many types of interpolation methods. So the first one, you have the linear interpolation. This one, of course, used for the straight line between 2 points in space. All right, and then you have circular interpolation. All right, so maybe you want the workpiece to have an arc. All right, a circular path. Okay, so you need to define the starting point, the end point, and also the center of the circular path. Or you can use radius. This one we'll see in more detail in next lecture. All right. So and then you also have the helical interpolation. All right, and you can also have the parabolic and cubic interpolation. So these two maybe we don't cover in this semester, right? So if we have time, we'll cover. But if we don't have time, maybe we'll only focus on these two interpolation methods. Okay, to make it easy, as long as you get the gist of CNC programming, then I think the one is fine for you, right? Okay, so apart from interpolation method, you also have the absolute or incremental positioning, right? So of course, this one you also need to specify in your coding. We'll see how to do it after this, but this one I just want to share, you know, the things that you need to know before you code in CNC. So either you can code your path using absolute positioning. Okay, absolute positioning. What does it mean? Locations defined relative to origin of as-is system. All right. Okay. So how about the incremental? Okay. Locations defined relative to previous position. Right. So we'll see some examples in the next. Right. So for example, the overhead is presently at point 2020. So let's say we have our tool at this position 2020 and is to be moved to point 4050, right? So it want to move to this point, right? In absolute positioning. So absolute, use just mention this point coordinate, okay? Meaning you just give 4050. All right, so that's for absolute. If incremental, have you have to mention the difference between, for example, for x-axis, you mention that this one need to go 20 in the x-axis and 30 in the y-axis. All right, like that. So this is incremental. All right. So instead of giving the absolute coordinate, you give the incremental coordinate. Okay. Right. Great. So if let's say the point is at here. All right. The point at here. So if the all right. So let's give. So let's say our point is here, for example. All right. So if absolute, you give the coordinate as 0, 10, right? 0, 10. Okay. How about the incremental? So for incremental, you go to, I think, minus 20. So this one is not very exact. Okay. So minus 20, right? So going backwards. So minus 20 as well as minus. So 20 minus 10, right? So in the negative direction. So minus 10, like this. Okay. Right. So this is the absolute and incremental. So of course you need to, define this, whether you want to use absolute or incremental in your programming. How to do it, we'll see after this. Okay. And then you have the computer numeric control. Okay. So this one is a feature storage of more than one part program. So you can have multiple of part program. Okay, so you just specify program 1, program 2, and so on. We'll see after this. And various forms of program input. All right, so you can have lots of inputs. Program editing at the machine tool. All right, you can edit directly in the machine tool or in the computer. Okay. Fixed cycles and programming routine. So this one, for example, if you have the item in batches, so you can fix the codes and run for many times. Okay, so you don't have to code every time new item come in. All right. Okay, interpolation, acceleration, communication interface, diagnostic. Okay. Configuration of CNC machine control unit. Okay, so this one as normal, like a computer. All right, applications of CNC. All right, milling, drilling, turning, and so on. So this one you see by yourself. Okay, this one is an example of what? Turning, right? Turning. So this one will rotate in this axis, all right, or in the reverse. Okay, and then you move this one, right, either to the right or to the left. Okay, and this one will of course create some chips, which is not good for your environment. Okay, okay. Right, and of course while doing this, you need to feed some liquid, right? Otherwise this one will create a very high temperature, right? Of course will deform your either will deform your workpiece, or it will cause fire. Okay, so I think this one you already seen this in your lab or your workshop, right? So this one drilling, milling. Okay, CNC horizontal milling machine. So you have lots of CNC machines. Okay, so here you only cover on the one with the cutting tools. So you can go to YouTube and or Google. You can see lots of modern CNC using other methods of cutting as well. So for example, nowadays people use plasma, right? Plasma, and some of them using water jet. Okay, water jet with of course with a very high speed, and then lots of other types of chemical base as well, chemical based CNC, all right, and so on. Okay, where CNC is most appropriate, batch production. So this one of course for things that have the repetitive works. Okay, complex part geometry, of course if it is done manually, is very difficult. So you just program so that the machine will do this part. Much metal needs to be removed from the starting workpiece, so it's very cumbersome if you want to remove lots of things from the workpiece. Okay, so you don't want to cut one by one, so you use the milling machines to do that for you. All right, and then many separate machining operations on the part, and the part is expensive. All right, so this one because it's expensive, we need to make sure that all the cutting process is accurate as possible. Okay, so that you won't waste any parts. Okay, okay, this one you go by yourself. The advantages, disadvantages. Okay, right. So one is the positioning system. Okay, so this one is the work table, right? You put the work piece on the table, right? And then you have the cutting tool here. Okay, and then you can move the work table around, right? So this one you can fix. Okay, the what the workpiece you can fix on the table, all right? Okay, and then you can move this. Okay, okay, this one you go by yourself. Okay, closed loop, open loop. All right, so now we come to the CNC part programming. Okay, you'll see manual part programming. So it can be manual part programming, computer assisted part programming using CAD/CAM, manual data input. Okay, so inshallah in this class we'll see on the manual part, because all of the other is just the same. Okay, So CNC instruction are called part. Okay, when running a part program is interpreted one command line at a time until all lines are completed. Commands, which are also referred to as blocks, okay, as blocks or the lines, are made up of words which is begin with a letter address and end with a numerical value. So this what I mentioned before. You will have the letter and numerical value, the number. Okay, so you have to specify which part should be loaded on machine spindle, what are the cutting conditions, right? When the motor should turn on or turn off. You need to specify the feed, right, or the feed rate, okay, and then when to start the motion and the start and end point of the motion, right? How to move the tool with respect to the machine. Of course, this one you need to know the coordinate system to do that. Okay. All right. So this is the example of the alphanumeric code. All right. So you will this one follow the standard of ISO. So you need to make sure that you always follow this, the instruction, the sequence of the instruction. Right. So for example, it will start with N. Okay. Okay, we'll start with N here, and then G. All right. So this one you call it N code, G code. All right, G coding. All right. So and then this is the location that you want to go. Okay. And then okay, we go first this one. So N is sequence number. All right. So or you can call it line number. Right, the line. Right. In CNC they call it block, which is quite confusing. Okay. So you just call it line. All right. So N3 meaning that line number 3. Okay, and then G2. G2 is G code is a very important code for movement. So this one is preparatory function. So we'll see in more details what it offers for the machining. Okay, and then you also have the XYZ coordinate here, the destination. All right, the place that you want to go. Okay, and then in some application you might use some circular motion. Okay, circular motion where you will need to specify I, J, K. All right, the distance from the destination to the center of the circle. All right, so how to do that we'll see after this, inshallah. All right, so but you need to make sure that you follow this sequence. Okay. All right, so N, G, the location. All right, so if you have the circular motion, you need to specify the I, J, K. All right, and then F. F is the feed rate, right? Feed. So for example, this one is your tool. How fast you want the tool go, right? In which direction, right? So like this. So this is the feed. Okay. And then you also need to specify the spindle speed. Spindle speed is the you can call it rotation speed of the tool. All right. And then T code is the which tool you want to use in this program. So let's say T4 meaning that you want to choose the tool number 4. Okay. So of course in the CNC machine you can put a lot of tool with different sizes, right? Different length and different depth and so on. So you can just mention which tool you want to use. And then M2. What is M2? This one call it other function. You know, M always something that need to do with the machines. Okay, right? The machines or the motor. Okay, whether you want to turn on or stop the motor and so on. Okay, so these are the standard sequence of the CNC. All right. Sorry, each letter address relates to a specific machine function. G and M letter addresses are two of the most common. G letter specifies certain machine preparations, right? So for example, you want to use inches or metric mode, right? So inches or mm, right? Metric. Or you want to use absolute positioning or incremental, you need to specify using G letter, right? So as for the M letter, you can specify miscellaneous machine functions and work like on off for coolant flow, tool changing, speed rotation, and so on. Okay. We will see the list after this. So important thing to know before we move on: coordinate system. All right. Units. Okay. Let's say I give you the this bottle, right? Coordinate system, right? Much like your cat, right? So how if you see from this direction, okay, how would you draw uh, the view, the isometric view? All right, okay. So this of course need your creativity and your knowledge in coordinate system. All right. So where is the one with the hollow and so on? Okay, coordinate system. So coordinates, what is x, y, z, rotation with respect to x, rotation with respect to y, and z. Okay, and then the feed rate. Okay, feed rate, spindle speed. This one will be given. Okay, coolant control. Okay, tool control. Okay, so this one is the cutting speed. This one the theoretical parts, right? So this one you go by yourself. Okay. Okay, this one I've already mentioned this. Okay, programming key letters. Okay. Program number, sequence, preparatory functions. This one we already find this before. And then you can also find this H for tool length offset. All right, so this one we'll see after this. And then maybe you can have the D, right, for the tool radius offset. Okay, when you specify this, you need to give the H and D, right? And then T we see before, and M, right? Okay, so first thing first, before you start your coding, you need to specify or you need to set the work datum, right? Work datum here, right? WCS, where's WCS? Workpiece coordinate system. I think coordinate system, right? So work coordinate system, this one is machine coordinate system, right? So you need to specify the work datum. So let's say this one is your work datum at this age, right? So how to do that? All right, so you move the work table to reference point, you fix this one, attach a dial gauge or fix the reference tool in the spindle. Okay, you put this yellow thing in the spindle, right? And bring the tool towards the workpiece, right? So you slowly you move this to here, or manually, and make the tool to touch on the surface of the workpiece and note the Z as it's reading. So this one you go down, cannot see in color, right? So you make this one down, touch the surface, okay, right? So and then you can note in your program the Z value, okay, and then add the tool length with the same sign to get the Z coordinate value and note down this value. All right, okay. So when this one touches this here, so this you can see the datum. This is your datum, right? Or you call it work coordinate system, okay, or work datum here. All right, then move the tool to any one edge. Okay, this one, and then move the tool to any one edge and make the tool to touch the edge and note down the readings of X and Y axis. Okay, so you touch to the yellow parts here. The tip of this, touch this yellow and see the value of X and Y, right? Add subtract the radius of the tool from the readings. Okay, the reading will be the distance, so this one will be recorded in your coordinate system of your CNC, right? Record noted XYZ values in any one of the work coordinate G codes, right? So this one you can so for normal CNC you can store this in G54 up to G59, right? So 54, 55, 6, 7, 8, 9, so up to 6 work coordinate, different work coordinate that CNC can store. Okay. All right, so these are the list of G codes, important G codes. So G00 rapid transverse, G01 linear interpolation, G02 circular interpolation clockwise, G03 circular interpolation counterclockwise. All right, so this one work in which plane? Right, so default in the SY plane. Right, so G20 or G70, so this one depends on the type of CNC. Some CNC use G20, some CNC use G70. So this one, if you want to use inches, all right, so maybe in your drawing it is in inches, which is not very usable in Malaysian industry. So Malaysian industry always use metric units, okay, as well as in our academic as well, right? We use metric unit. All right, so inches more used in, I think, in UK or something. Okay, so G21 or G71 is the metric unit. So if in millimeter, for example, right? So machine reference, home, just 54 use a different reference, right? So you can specify the datum using this. Cutter compensation cancel. All of this we'll see in much detail after this. So this one will just go through the list. Right, G42 cutter compensation right. All right, what is cutter compensation? We'll see after this. Okay, and G43 tool length compensation. All right, so of course when your tool want to go up and down, you have to include the compensation, okay, for more accuracy. Okay, so this one plus minus. G49 tool length compensation cancel. G90 absolute positioning, G91 incremental positioning. Okay, all right, so we'll see the first one, which is the rapid transverse. Okay, rapid transverse. So G00 rapid transverse. Okay, so you have these two code, G00 and G01 for the linear interpolation. Okay, so and this one you need to be careful. If you see closely, G00 after that will be followed by the location that you want to go, the destination. Okay, so as for the G01, it will be followed by the destination plus the fit rate. Okay, you need to specify the fit rate, because the G00 doesn't need the fit rate, because it will go as fast as possible that the CNC can go. Okay, so for example, you want to go very quickly to the datum, for example, or for example you want to drill, right? So you drill, you retract and you want to go to the next position, instead of going slowly to the next point, you go very fast, right? Because you know that the path have the clearance, so you go very quickly, and then drill, retract, move quickly, drill again, right? So this one will of course will save you lots of time. Okay. Okay, so and for the G01, you need to specify the feed rate. So this one normally used for of course, if the drill, you need to specify the feed rate for the Z axis. Okay, and also for the milling. Okay, so you need to go slowly. All right, for the cutting. Okay, that's for G01, G00, G01. All right, so if you want to use G00, of course, safety first. You need to make sure that the path is clear. There is no, nothing that blocks the path for the cutting. Otherwise, if your spindle hit something, the workpiece, then it will be very troublesome. Okay, because it went very high speed, the high speed of the spindle. Okay. Okay, G0 for fast positioning, rapid motion. G01 for slower cutting motion. Okay. So all the machines may dogleg G01. So in newer machines, if you specify G00 to go from A to B, right? So it will go like this. In older machines, instead of going like this, we will go like, take some dog leg, you call it. Okay, dog leg, to go to the destination. Okay. All right, so that's for the linear interpolation. So now you also have the circular interpolation. All right, circular interpolation. So you use it G02 and G03. All right, so for G02, you use this for clockwise motion, G03 for counterclockwise. Right, so how you want to invoke this? You just call it G02 and then your destination. All right, X, Y, Z. If you need Z, but of course, if you have circular, normally you will be in a plane, right? So normally maybe XY only, or XZ or YZ, right? So normally in the plane, okay. So you specify the next point that you want to go, X, Y, and then look here, we have something in the middle. So you need to specify the feed rate as well for the G2, right? So this one, IJ, right? What is IJ? Here, call it the center of the circle, right? So it's not exactly the center of the circle. So if you go back, yeah, this one. If you go back to here, it's not the center of the circle. So IJK, so this one is with respect to X, with respect to Y, K with respect to Z, right? So it is the distance of the next point to the center of the circle, right? So for example, in our example here, right? So let's say we are in this point 01, and you want to go to this one, this point, the next point here. Okay, so let's say the point is here. Okay, 1.28 and 1.53. Okay, and then you want to make a circular motion. Right? Let's say you specify G02, which is the clockwise, so we'll go like this. So if you specify the G03, you will go like this because it is counterclockwise. Okay, counterclockwise. and then you need to specify the center of circle, so ij. So let's say the center of circle here, right? Center of circle here. Let me use another color. Okay, center of circle here. Okay, so I is the distance from the center of circle to the what? To the point. Okay, so this one, right? Okay, so this, okay. So it's not to the destination, it is from the center of the circle to the point that you move, right? The point, the first point that you move from. Okay, so let's say you want to move from here, so you calculate the distance from this one in term of the x-axis. Okay, so this one is I. Okay, and then you also need to find the j, which is the distance from the center of circle and the point. So as for this example, the distance is 0 because it is in the same y. Okay, same y. So here the j is 0. Okay, because there's no distance there, right? So if you opt for G2, it will go like this. If G3, like this. Okay, counterclockwise. All right, and then you also need to specify the feed rate. All right. So you have the linear interpolation and then the circular interpolation. All right. And then of course, if you want to choose your plane, you need to specify as well. G17 for X1, SY, G18 for XZ, G19 for YZ. So this one, but in most of the time you will use this one for milling, right? Okay, so I think we'll stop at this point. Okay, inshallah, tomorrow class will continue from this point onward, inshallah, and we'll see some examples of the part programming, to do milling and drilling, inshallah. All right. So with that, let's end this class with tasbih kafarah. Subhanakallahumma wa hamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.